each smart vehicle contain of multiple small computers which are connected and communicating with each other. To secure such an environment, you need to think about a comprehensive solution, and will include the prevention in the first place. You need to develop a secure software for this vehicle. Then you need to think about monitoring. While the vehicle now in the field, you need to find a mechanism which will be able to detect this attack. And not only but we need also to think after, what if we receive or we get some attack, what we will do. So we need some kind of, let's say, let's call it response or mitigation mechanism that need to be applied.
Welcome to talk.cybercni.fr.
Bienvenue.
Welcome to Talk CyberCNI. Today already the 13th, no, the 12th edition, because we had in 1 month we had 2 editions. And yeah, as always, welcome to your monthly cybersecurity speaker series, with which we want to raise awareness on cybersecurity topics. And also today we have a very exciting guest, namely Mohammad Hamad. But before I introduce him, let me briefly share with you another interesting news. Those of you who joined last time, they know it already, that we are currently preparing for next week, because next week we'll have the 4th Future IoT PhD School on IoT meets cyber and security. It will be an exciting week with lots of interesting keynotes. There will be a program on site. This is, of course, the most interesting. For those super short deciding, you could still contact us. There's still a chance to be on site. But for all the others, we also have 2 options of remotely participating. So we have free live streams. They will be on YouTube. They will be on LinkedIn. They will be on Facebook, like the series today. And we also have a Zoom. The Zoom will, of course, be more interactive, plus you'll have the possibility to present your PhD work and to do networking with the other PhD candidates. Both options are also available, as well as the program on the website. So check it out and join for talks. You can also, when you think, oh, this talk is interesting, you can also join only for selected talks. You have quite some flexibility. Exciting week next week. But now let's return to today. So to the talk of Mohammad. So the title of the talk is a multi-layer cybersecurity framework for the Internet of Vehicles. So we go once again to the Internet of Vehicles, and we had some talks in that direction. Mohammad will have another view on it, which will be very interesting. And yeah, let me briefly introduce him. But before we do that, as usual, you have the possibility to interact, and for that we have the Slido. We'll also have Alex on board again today for moderating the questions at the end. And you know it already if you participated in the series before. This is the second screen that you can use during the presentation. You can ask questions and see what other questions are asked, so it makes sense to participate in any case in the second screen. As usual, we'll put most of the questions into the discussion at the end. So whenever you have a question, add it there. And when you think the questions that are there are cool, vote them up so that we see, okay, this is a very good question. Many people want to hear it and can prioritize the answering of it. All right, so code, as usual, CyberCNI -12. You can follow the QR code, or you go to slido.com and enter this code to go and ask the questions. I will show it to you also, as usual, on the slides, so you will see the code also during the presentation. Good, then let's go back and introduce Mohammad. So it's my great pleasure to have him today for our speaker series. Mohammad Hamad is a postdoctoral researcher in the Embedded Systems and Internet of Things group in the Faculty of Electrical Engineering and Information Technology at the Technical University of Munich. Mohammad joined TUM, Technical University of Munich, in April 2020. Before joining TUM, he worked as a research staff member at the Embedded Computer Security Group at the Institute of Computer and Network Engineering at TU Braunschweig in Germany between 2014 and 2020. And in 2020, he obtained his PhD from the same university. His PhD topic was about in-vehicle security. So as you see, he works in the field for quite a while, which is great because then he can share lots of interesting insights with us. Mohammad's research interests are autonomous vehicles and IoT security. During his work at TU Braunschweig, Mohammad participated in many EU and national projects. Now at TUM, he's leading the TUM research activities in the EU Horizon 2020 IOV project, and he'll also report a little bit about that. I'm sure about that. Good. So without further ado, Mohammed, I am very happy to welcome you, and I hand over to you. The floor is yours.
Yeah. Thank you, first of all, Mark. Thank you for having me here and giving me the chance to speak about my previous and current research at TUM. And I guess before we start, maybe it's a good idea to speak a little bit about Innova. So Innova is an EU project that we are running now in TUM, where it's also interested to create some kind of multi-layer cybersecurity framework for the internet vehicle. And from there, the title of my speak will be. And to give more idea about what kind of vehicle we are speaking about it, I guess nowadays vehicle is not only four wheels and engine. It's now moving to become like a network on wheels. So within our modern vehicle now, we can find a multiple small computer, which is called ECU. And this can be from 70 to 100 ECUs. And all this computer, they are interconnected with multiple type of communication. So we can find CAN, LAN, MOST, FlexWay, and ever recently we can find an Ethernet. Not only that, but also now the vehicle is able to communicate with outside world by using different smart sensor like the GPS and the Bluetooth and wireless sensor. Also, the idea of all this connectivity for the vehicle was to bring more safety and comfortability to the driver and to the passenger. Of course, there was a bad side for that because it was introducing a lot of attack surface for the vehicle. And I believe most people who are working in the automotive and mainly in the security automotive domain, they remember this picture where Charlie and Chris, they were able to hack the Jeep at 2013, 2014. And I guess this was the big shock for the people who work in the domain because they recognize that the vehicle now is really under attack. And hacker, they will be able to, in the future or even can't now, they compromise our vehicle. But is it really, this is the case? Is this was the only evidence? Is this was the last evidence? Actually not. Because even before in 2013 and 2010, there was an evidence that the smart vehicle or the connected vehicle, they were vulnerable to multiple attack. And I give an example, 2010, there was a researcher, they were published a paper about the tire sensor. And this tire sensor was vulnerable to multiple attack. And at the end of the day, the attacker, they will be, or the researcher, they will be able to cause some malicious or serious consequences to the vehicle. The most interesting thing that was, if you Google, you can find an article which is in 2002, and people, they were speaking about how I can hack my car, for example. Although this wasn't about, let's say, malicious things, it was about how I can, for example, manipulate the integrity of my software to get better performance. But as I was saying, the story wasn't end at 2015 because in 2017, for example, there was a famous attack from a Chinese researcher group. They will be able to hack or attack Tesla for the second time now. And in 2019, also there was an attack against the startup, export thousands of car to hacker, so the startup application. And in 2020, also there was a vulnerability in Volkswagen cars, which was also lead of real issue. Is will be the end. We don't believe so, and I guess in even the near future we'll find or we'll read more attack about this. And someone can ask, who is attacking this smart vehicle and how they are attacking this is. And there's a recent report from Upstream. They said almost 50% of this attack is coming from black hat hacker, which means that the intention is to do something bad. And in the 2019, also from the same company, there was another report showing, okay, how this hacker, they will be able to access the vehicle. And we can see that in 2019, for example, almost 80% of the attack was remotely. So the attacker doesn't need to be inside the vehicle to launch an attack. And after looking at this, somebody also can ask why, from where all this vulnerability, where's the issue with our smart vehicle? And the issue started from the network. So if you look at the topology of the in-vehicle network, we can see that it's kind of heterogeneous network, where with this, all the ECU that I was speaking, and then somehow they are able to communicate with each other. So everyone is able to speak with everyone, although there's some kind of gateways. This is, for example, all topology where we have the central gateway, but then somehow some ECUs, they will be able to speak or to make issues for other issues if they are compromised. Also, the problem was people, they think that the vehicle is by itself isolated. So if the attacker would like to attack the vehicle, he or she need to be inside it. But within all this smart sensor, this wasn't valid anymore, because now attacker, as we showed, they are able to attack the vehicle from outside. Also, some of this protocol that the ECU they are used to communicate wasn't designed with security in mind. And the famous example here, the CAN, the first version of CAN, there was no security, let's say. Also, the other problem that we have, the low criticality and the high criticality devices coexist. And even if somebody thinks that, okay, I will isolate this with another network, for example, and I have the other low criticality devices in another network, this will not solve the problem. Because as I was saying, at the end of the day, if one of these devices, the low criticality devices was compromised, this may lead to other devices to be compromised also. And as we said, the network and the attack surface, because the vehicle has some kind of internal attack surface like the OBD board. Even there was cases where the disk or the entertainment head was used to launch some attacks. The outside, also the remote attack surface, is the main target for the attack. And as I was mentioning, the tap versus sensor, the Bluetooth and GPS and satellite radio. What is other problem? If you look at the figure, we see how many code we have in our modern vehicle. And you can see that almost we have 100 million line of code. And if you compare it to the, for example, Boeing 787, the modern vehicle, they have, I guess, 10 times more code than the Boeing 787. And the problem is this code has multiple level of security and criticality. And also this code, not all of this code was written with security in mind. And I can give an example about attack against Tesla S, where they were running for their entertainment system, they were running some kind of Ubuntu-based system. And let's say the researcher of the attacker, they just nmap this and they found some kind of open board like Telnet and SSH, which is still there, which is you don't need to have them. So even some people, they just look at the commercial of the shelf code and adapt it a little bit and use it without also thinking much about the security there. Other problem, even if we would like to write a secure code, this is difficult because it costs the money and the time, and you need educated people to do this, and we don't have this. Other problem, which could be also really critical, which is about the safety and security. There's always some kind of misunderstanding between this. And I always say that, especially for Germany, because the safety and security, they say they have the same word, Sicherheit in German, and people sometimes they confuse between them. But actually, if it's not secure, it's not safe, which means that this is two different domains. They can interact to each other, but at the end of the day, we need to be sure that our system is safe and secure, not only safe. And of course, just doing some kind of functionality and safety test will not ensure security. And even though, I mean, even if we think that people, they may do some kind of security test, there was a recent report, which was, I guess, in December 2018, January 2019, where they surveyed 593 professionals who are working in the automotive domain, and they were asking them some question about the security. And let's say the bad or the amazing thing that 30% of the people, they say that they don't have any product cybersecurity in their organization, which means that not even part of the software will be tested. They are not having security at all. Also, 60% of them, they say they already test half of the hardware and the software from the vulnerability. And as I said, all this is, let's say, bring a lot of issues for the automotive security domain. And after all this attack, after all these challenges, we can have some lesson learned here. And the one and the important one, that looking at the prevention only or having prevention mechanism is not sufficient. As I said, writing software, secure software, this will not work because, or even testing this will not work because till today, for example, we still have some kind of vulnerability like buffer overflow, which is almost from the 70s. Some people, they're mistaking because they believe whenever we speak about security, let's have crypto, but the crypto will not solve everything. Crypto is just a tool, okay? And also whenever I look at looking at the network, for example, and isolate the critical from the non-critical, and having, for example, these gateways, this is also would not solve. And I can refer here to the Miller in his article in 2019, and he was saying that although and then the Jeep, they have such kind of gateway which isolate the entertainment system from the other system, but because they did not think about the security for this gateway, they will be able to compromise the code and run their own code there. Also, another thing that we learned that with detection also, it's not enough. So you need to have prevention, and also you need to have a detection, which is important, but still not enough. The detection is important because we will be able to detect some kind of zero-day attacks, but it's not enough alone because it's not giving us, for example, the protection mechanism. So as I was writing here, it's passive detection. So it just tells us that there's an attack, which leads us to the third, let's say, lesson learned, that response is critical as the detection of the attack. So we need to find a way, even if we try to prevent the attack, try to detect it, and after we detect it, we need to respond to this attack. And by looking at all these three lessons, we say that it maybe will be a good idea to have a framework which cover all these three principles: the prevention, detection, response, and have it in multi-layer framework. Within each layer, for example, certain security activity need to be performed, and this activity, they interact with each other to hopefully end up in a kind of secure framework for the automotive system. I will go for each one of this layer in much detail. So, and within each one of this layer, we will tell what the issue and how we try to solve it. I mean, during my PhD and during our research now in TUM. And if we start about the threat modeling, if you look at the ISO 26262, there wasn't much security there because they just say, okay, you need to use a Tara. And later when the SAE G3061 showed up, and lately even the ISO 24343, they already say that we need to have some kind of threat modeling. But I just quote here from the SAE G3061, they said it's left to the organization to determine which Tara method is appreciating for their process. So they did not define which process that I need to use to do, for example, threat modeling. And when we look at the let's say, the literature, we found multiple way to do threat modeling. So there's threat modeling which is asset-centric, like TVRA and Octava. There's attack-centric, and like the Intel TARA. There's the software-centric, like CIA. And we said, okay, I guess by looking at or using one of these threat modeling approach, we believe that this will not identify all the threats, and it may lead to insufficient mitigation mechanism. So our proposal was to provide something like a hybrid threat model, which try to look at all these threat models and put them in one model. And we called our threat model SAFTA. And this threat model was aiming to answer three main questions. The first question, who are we facing? So we need to look at the attacker who would like to attack the system. And by looking at them, we need to see what kind of skills they already have, what kind of access they are able to reach our system, for example, what the resource, the tools that they are using, and looking at their motivation also. And also we need to look what do we have. So by focusing on the assets that we have it in our automotive system. And from there, we just say, okay, we divide it in four categories. The first category, which will be in-vehicle hardware. The other one will be the software and the firmware, which is running on this hardware. The third category, which will be the data, whether this is exchanged data or stored data. And we have finally the surrounding infrastructure. And after we look at the attacker and we look at the assets, we said, what do we need? Okay, what do we need to protect? So this will tell us what kind of security requirement we are looking for. And we just look at the extended CIA, where we look at the confidentiality, integrity, availability, and authentication, authenticity, and authorization. And by combining all this, we come up with a framework which is start with the assets, and within each assets, we see what kind of requirement we are looking for there. And from this requirement, we see how the attacker will be able to manipulate this requirement, whether it will be direct or remote, or could be direct and remote mixed. And from there, we define some kind of goals that the attacker they would like to achieve. And from these goals, we use the attack tree to build the tree, which will lead the attacker to reach this goal. And I will just show here a small example about the autonomous vehicle driving. And we just focus, for example, the camera. And we said, okay, by applying the model that we already have, we can look at that we have the hardware, we have the data, we have the surrounding infrastructure. And based on each one of them, we just say, okay, for example, I'm not sure whether this is readable very much, but if we look at the roadside, okay, we say maybe the actual attack or actual requirement could be the availability and the integrity. And we said how the attacker will be managed to, for example, violate this. And based on this is also we create the root of the attack tree, and we start building our attack tree. And also we link this is to the threat agent. And the threat agent here, as we said, we need to specify what kind of motivation, and we look at the skills and resource and etc. And after defining our security requirement, we said now we need to create some kind of security policy which translate the security requirement. And to do this is we were facing the problem that where I should define my security policy. And usually people, if you look at the V model, okay, in most cases, we define our security policy during the implementation and the integration. But by doing this there's a lot of problem, because this is, in the first place, it's really difficult and complex. And as I said, we have multiple ECUs, we have multiple communication, we have multiple security requirement for each one of this communication. And waiting until this later stage, this will be too late, because the attacker just need one mistake, doesn't need to have 5 or 10. If you just manipulate or mistake one of this requirement, you just open a gate for the attacker to jump into your system. Also, the other critical things here, because we said if there's some kind of requirement which was defined in the design phases, who or how we can ensure that this will not be violated while we are doing the implementation and the integration. And this is also another problem. And the other thing now, if you look at the vehicle, when this vehicle need to have, for example, new software, new hardware, we said now waiting until also this case to build a new security policy, this will be a lot of time, a lot of cost, and also will bring a lot of errors. So our proposal was to create also a way to integrate the security policy development through the whole different phases. So we start with the requirement, and whenever we go to the design people who will create, for example, this other security policy, they need to re-implement the one that we have it in the requirement. And we will start, for example, very abstract, and we'll end up at the implementation and integration in very detailed security policy. And this is very important because by doing this is we kind of decoupling the security policy from the functionality of the application. The other important thing now, how I can ensure that this will be respected. We say that we can implement this is using the trust management. And how we said we can do this is we say that we need to have to look at the system at multiple tier. So we have the functional tier where we just specify, for example, our functionality. And we just define here some kind of security requirement. And here it will be very abstract. Then when we go to the component, we know that all this, each one of this functionality, it will have some kind of software component. And now we have more detail, which one of the software component will be used to communicate with other one, which means that we have more capability to express our security policy here. And whenever we reach at the integration layer, now we already know, for example, where this functionality will be mapped, and what kind of communication also they will use, and what kind of security that we are able to provide. And I have just an example here where also we have the autonomous driving, and we say that if I would like to look at the target position generation and the static environment modeling, we just say, okay, we create the software component for what this is. And here I just say, okay, for example, I'm looking for integrity. So between these two components, the most important thing now, the data should be, the integrity of the data should be saved. And whenever we go for the final integration, we know now, for example, that this will be mapped to two different ECU, and now we know which port will be used. If we consider that this will be used Ethernet-based communication. And also, we will be able to define the IP addresses of this ECUs, the port, and also we can say that we would like to use integrity, and how I can use integrity here, since we are communicating ECU to ECU, we can use, for example, IBCKH. And as I was mentioning, we need to find a way that the provenance of the policy need to be respected. And we say that this can be done or implemented by so-called trust management. And during our research, we were using Keynote Trust Management Library. And this is by, when we start with one node, the one node will delegate the trust to another node under certain condition. This node that received the trust from the original node, it's now able also by itself to delegate the trust to another node, and another node will be add further condition. And now whenever we would like two components to communicate, for example, we just need to find a trust path between the requester and the root that everyone is trusting. Now, after we have, for example, our security policy, we need to ensure the security for the communication. And also we face certain problem here. So now I have the security policy, I would like to enforce it. And the question is where I would like to enforce it. So if we look at the topology for in the vehicle communication, we can say the old one where we have central gateway. We have the domain-based communication where within each domain we have a gateway. And the idea could be, okay, I could enforce the communication within the central gateway, or even the central gateway on the other domain gateway. But this is also problematic because if we look at this case, this will be single point failure. So the attacker, if the attacker were able to compromise and this, for example, the example of the Jeep, now all the vehicle under control of the attacker. In this case, it will be better, but we still have, for example, here the communication between the ECUs within one domain. This will not be protected. And most of the solution, for example, they said maybe the easy way to do a security between domain to domain. So the communication here, it's still clear text, but whenever one message in this domain one would like to communicate with another ECU in the domain 2, I would like just to, for example, ensure the integrity or the encryption of this message. And we say that this could be not the optimal solution. And our goal was to define or implement so-called distributed firewall. And what this distributed firewall meaning that we don't put the policy enforcement in the gateway, on the domain gateway. We put it in, let's say, each ECU. If the ECU is capable to do this policy enforcement, we just create and distributed firewall within each one of these ECUs. And how this distributed firewall look like, we just implement something called security module. And within this security module, we have 4 main components. The first one, which is the proxy, which will be responsible for the receiving the request from the software component. We have also a policy evaluation system, which will be responsible for evaluate the credential. And whenever, for example, we finish the evaluation and we need to store the decision here, we use something called decision repository. And after that, all the communication need to go through some kind of communication system. And in our case, we were using lightweight IP stack. And to implement all the security, we just create embedded IPsec inside this communication module to ensure the integrity and confidentiality of all this communication. This is the protocol, for example, how to start setting up all the policy and to end up with the rules. And this will have 2 phases, the initiation phase and the operational phase. And during the initiation phase, the software component, they need to exchange the credential that they already have, and that we build it from the, let's say, the design until the implementation, until the integration. All this credential need to be exchanged and need to be evaluated, and then the result need to be stored. And whenever we done with this phase, now the communication between, for example, the software component 1, software component 2, will be protected based on the decision that we already have. And we will use, in our work, we were using IPsec to secure this communication. Of course, there's an overhead for this, and the overhead is high. But the idea here, you need to do this as a once. So if you would like to turn on your car, you just maybe do all this operation at once, and then whenever this is done, you are able now to, for example, use the exchange of session key to ensure the security of the communication between the 2 components. Maybe some word about why the overhead is coming. Mainly it's coming from the signature and the verification of the signature within each credential. So also using some kind of crypto accelerator or caching this credential, and somehow maybe also improve the performance of this stage. Now, we spoke about the prevention mechanism, and now we would like to move to the intrusion detection system here. And in our case, we said that using a signature-based intrusion detection system is not a good idea, because usually whenever we have a car, this car designed to work, for example, for many years, which means now if there's a new vulnerability, we need to have update for this vehicle, and we need the over-the-air update system. And till today, this is not, for example, functional 100%. It's also always behind. So because whenever we have a zero-day attack, this mechanism will not be able to detect it. And we will have this attack in our vehicle until we get the update. And because of that, the behavioral-based intrusion detection system was, for example, introduced not even in the vehicle, but in other domains. And the problem here within any behavior-based intrusion detection system, that how we can define the nominal behavior. And here, either if you have, for example, over-approximation, which means that this will introduce a lot of false negative, and this will introduce us a lot of security issues for our system. Or maybe whenever you have your intrusion detection system, you are under-approximated, and this will lead for a lot of false positive. And this will manipulate the safety, because usually what we already have, we have something called binary decision. So whenever I have a software component or a hardware component, for example, and they are malicious, usually the answer is we need to stop this malicious component. This is how we think about it. But now if we have, for example, under-approximated intrusion detection system, which will introduce a lot of false positive, if I would like to stop all this component, now I may violate the availability of this component, and this will lead to safety issue. So we said maybe this binary decision is not the optimal things for the automotive, and we need to think about something else. And what this something else, we said we need to move from binary decision to multiple decisions. And we said how we can find these things, we said usually whenever you have a component, you just say, okay, this is the policy which will define the normal behavior. And we said, okay, whenever the policy it's outside this envelope, for example, this will be abnormal and I need to stop it. But in reality, this is how the task will behave. So, and the reason for this is there's many reasons, because maybe even while you are doing the testing to define the normal behavior, you will not be able to test all the functionality in the system. And now even this could be normal, but if this is because it's violating your policy that you defined wrongly, now we will end up an issue. And what we said maybe the good idea is to introduce a new area, and we call this area the red zone area. And will be a window of observation. And during we will look at the task that behaving maliciously. So we just say it's a prediction area. So I predict that the task is malicious, but I'm not sure. And we will stay waiting until this task, for example, violates some kind of ultimate limit. And this ultimate limit, I will be sure now it's the task is malicious. And what the advantage of this is will allow me, for example, to keep the task is running, even though I suspect that it's malicious, but now under something more controlled conditions. So whenever the task enter the red zone, I need to take some action, okay, to be sure that this task is doing something maliciously. So I need to trace it. I need to know what's going on there. Other thing that with the binary decision, okay, you have the task and suddenly you just cut it off or you kill it. And the vulnerability will still there, okay? So you will not get much information about this is by doing this is. So if you put this is under control or under observation, you may understand more about the behavior of this task. And this could lead us to better solution for the task in the next time during the editing. And of course, this area can provide us a mechanism, for example, how to, let's say, start so-called the response that I will speak about it next. So what the intrusion response system is meaning, I mean, if we look now about our vehicle, so let's say we have a car, suddenly we have an attack with this car, and what will happen, we need to just gather the information about this attack, and this is called the incident information, and we need to send it to the OIM. And after a certain time, the OIM will provide us with some updates, and then, for example, we are back to the normal life. But here the question is, how long this duration, okay? And I am just using one example from ANISA, which was published in 2019, and they gave an example about hacking or altering the V2X mobile application, which allow access to the car. And this vulnerability, for example, or this attack, the impact of it is very high. And what ANISA was proposing for this is, they say the recovery time from this kind of attack depends on the vulnerability and applying the patch, which may take days or weeks, which means that under the current condition that we are living here, you may have your car with a vulnerable software, and you may need to wait for days or weeks until you receive solution for that. And this is kind of, let's say, not the optimal thing. So we need to think about a way that we make our vehicle to respond, okay, to this solution. Of course, it will not self-healing, for example, but at least you need to prevent this software from speaking to other software, critical software, and wait until you get the update. But what kind of issue that we are facing to have such a system? The problem is, the first problem, who will decide and apply the response? So now the car is attacked. I need to do some certain actions. Who will do this certain actions? With a semi-autonomous vehicle, we still have the driver, and we can consider the driver like an administrator for the network. And he will be able to do certain actions. But the problem that we know that this will be problem somehow because the driver will not have the knowledge about what's happening. So he may not be able to select, for example, the optimal response. Now, whenever we speak about fully autonomous, the problem will be bigger because you don't have any driver. So the car itself need to decide what it will need to respond to this attack. And Other challenge for implementing such a system, if we look at the standardization and the guidelines, if we look at the ISO 21434, they already have something about the cybersecurity incident response and update. But as I was showing in the previous slide, it's mainly about whenever we discover some vulnerability, we need to gather information about it, then using over-the-air update or using any other mechanism to close this vulnerability. But this will not be the incident or the directly response to the attack whenever we discover it. As I said, the ENISA also, they do not speak about this. They also already spoke about the incident management and the response team. Other problem here, which is coming from the legal part, because traditionally, whenever we have any condition that may affect the safety of the driver, the law always say that this is need to be taken by the driver. I guess the thing is now changing, but we need also to consider a way that if the car itself would like to respond to a certain attack, this should be legally. So if we would like to design such a system, what we believe, we say that there's certain requirement for such a system. And the most important, the system need to be proactive. So the system need to predict the attack and not wait until the attack is happening. The system, the intrusion response system that we would like to design it, need to be dynamic. So it will be responding based on the operational mode, on the attack severity, or on the target system that it's under attack. It need to be active. It's not like the intrusion detection system just send me alarm. It need to take certain action. It should be heterogeneous. It should be also efficient because we have some kind of constrained devices in our vehicle. Also should be distributed. The optimal things that we have within each ECU or within each, let's say, domain, some kind of intrusion response system will be responsible to take response. Other critical things need to be deactivable, which means that after a certain time, I need to stop the mitigation that I take. So if I have an attack, for example, I said I would like to change the firewall rules. After the solving the problem, I need to back to the normal life. Otherwise, this will also introduce availability issue. How the intrusion response system can interact with other systems, we say by looking at the red zone principle that we were providing, we can see that IDS can run in the normal behavior. Whenever we have an alarm, this should start the intrusion response system. So the intrusion response system mainly will work during the red zone. And whenever we have we reach the ultimate bound that I was speaking about it, now we know that there's a failure. So someone else from the safety need to take an action. And we already provide some kind of framework to show how this is working and what kind of communication they would like to exchange between each other. So we still believe that, of course, we do not have this system ready, for example, and we still believe that there's a lot of things that need to be considered if we would like to implement, let's say, sufficient or efficient intrusion response system. And mainly, we need to look at the threat modeling because defining the response should also starting from a threat modeling process. So we will define some kind of, let's say, security vulnerability. And at that place, we need to say, if this security requirement was violated, what kind of response I need to take. Attack tree will be helpful because this also will tell me the cost of the attack, but it also may be used to calculate the cost of the response. Other thing which is about the dependency analysis, because we said within all this ECU interconnected, and we say that the violating one ECU may lead to violate other ECUs. We need also to consider this is while we are taking our response. And of course, we need some kind of policy that will include the response inside it. So to conclude, what is the lesson learned that we learned? I mean, personally, myself, during the work in my PhD about this is, it's obvious that the internet of vehicle without security, it's just an internet of vulnerabilities. So we need really to consider the security and give it high priority similar to the safety. Also, we need kind of holistic solution, which employ existing, for example, security mechanism. I still believe that we don't need to come up with new solutions. We already have from other domain multiple solutions. The idea that we need to look at this is maybe analyze it, adapt it, and bring it to the automotive system. Threat modeling is very important, and this should be the first step toward the secure system. Security policy also critical, and it should not be developed at the integration or at the implementation. It needs to be also integrated within every phase with the development. Integrity and authenticity and authorization are the critical part, and confidentiality come later, because we still, personally, I believe we don't need to encrypt every message inside the vehicle. This is not necessary, but at least we need to know who is talking to whom, and if there's any manipulation of the integrity of this message, this is really critical. So for some part of the communication, we need, of course, to have encryption, but this should not be everywhere. Lately, with a safety critical system like the vehicle, the response is critical as the detection. So if your vehicle able to detect some attack and it's not able to respond to this attack, it's a problem here. This is lead me to the last maybe slide. For people who are interested about each one of this layer, I just put the publication that we already published about this is. So within each layer, we have at least 2 or 3 publications. I would be happy, of course, to answer the question now, but I guess if you would like to learn more about all this is, you may need to look at this publication. And of course, this is also, let me thank all the people who were also working with this. So this work is not only my work, there was a lot of co-author here. There was a lot of people that working together to get all this, let's say, the framework and all these publications. And this will be the end. So hopefully you enjoyed. You learned something about our research. And in case you have a question, I'll be happy to answer them.
So now I'm not mute anymore for you. So yeah, wonderful. Thank you very much for the great presentation. I loved it. So it was great because you found exactly the right mix between staying a little bit general and going into detail. And so wonderful. Thanks a lot. I clap my hands in
Thank you.
Replacement of the missing audience or missing visibility of the audience. The audience not missing. We got lots of questions actually. And as usual, let me start with the first question. And the first question is a little bit detached from your talk, but it's also super attached to the talk. Namely, you're doing research in security for mobile systems, for vehicles. And so what is your biggest passion and motivation for being active in this research area?
I mean, this could be, if I remember when I started my PhD, because it was just a virgin domain. And there's a lot of opportunity that whenever you look, okay, you'll find some problem and something that you can provide something. This was really amazing for me because even if you look during my PhD, I wasn't focusing in one thing. I was looking at multiple things because, as I say, there's a lot of opportunity there. And because of that, I was just jumping from this domain to other domain, another domain to see how this is could help. And I can say that there's still a lot of empty spaces there, and there's a lot of work need to be done. So also for these people who are interested in this, I guess there's a lot of opportunity.
Very good, very good. So yeah, then as usual, welcome Alex, and I hand directly over to you for the first audience questions.
Okay, thank you, Makoiza. Thank you, Mohammad, for this very inspiring presentation. So there are a lot of questions today, so I will try to regroup them in packages. So we'll see if I manage it well. So if I do not ask your question as you quote it, don't be afraid of it. So first, there were questions about manufacturers and car as a tool, everyday tool. So, for instance, I will try it. Oh, yeah. Are manufacturers collaborating when it comes to the cybersecurity of vehicles?
If you mean that between the university and the industry, if this is the question, unfortunately not. I mean, we have a lot of problem there. I mean, even with the project that I was involved in, whether this is EU or national project, we have a lot of difficulty with the industrial because they have their own constraint. And I can give, for example, very nice example about the data. Okay, so the data is the big enemy for the industry. Whenever we ask about data for something, they just say, okay, we need to fill certain requirement, legal requirement, and this legal requirement will never ever end. So I was struggling during my PhD and even now during our work in the UOVA to find the actual data, for example, that we can use it to validate the mechanism that we already have. So I will say there's not that much collaboration there.
Okay.
And would you say that the car manufacturers between one and another collaborating? So I know, for instance, that in Germany, BMW and Volkswagen and Mercedes or Daimler, they are collaborating in some informal and formal rounds on different topics. So is there something like a global vehicular industry summit on cybersecurity where each company has a representative? Is there such kind of body?
No, I believe there's a lot. I mean, especially in Germany, you'll find a lot of this, let's say, the conferences and the workshop where the manufacturer, they sit and they provide, for example, and we already have a lot of companies also in Germany, they are doing cybersecurity. As I said, the problem whenever it's go to the research, I guess at some degree, the people, they don't understand each other. Maybe also there's a problem from us in academia, we are not really able to understand what the people in industry they are looking for. And sometimes we are speaking about something in 10 years or 20 years from today, which doesn't make a lot of sense for them now because they are looking for a solution that will be able to be applicable in the next 2 or 3 years. Between them, I cannot, as I said, I cannot say much because I'm not in that domain, but at least based on my experience between academia and industry, we have a lot of problems.
Good.
Okay. So there were other questions about manufacturers and polish insurance with cars. So according to you, which manufacturer does the most for cybersecurity?
Let's say
There are some tricky questions. You cannot answer if you don't want.
I mean, what you can also do is like explain a little bit what are they doing for cybersecurity. So in the concrete, if you know it, so are they do they have an incident database where everybody's sharing something, where they inform each other? Maybe you have some insights.
For example, this sharing for incident, there's already organization for the let's say manufacturer, not only in Germany, in Europe, and even the United States. I would say that some of the information that I was providing, especially in the first few slides, it could be historical because this is something when I was starting my PhD in 2013, for example. So now if you look at what the manufacturer they are doing, there's already solution where they have, for example, this kind of distributed firewall. So they are not enforcing, for example, the policy in the gateway. People, they are now thinking smartly. So you will have even people, they start thinking about having some firewall inside the ECU. So I would like to say that it's not that bad, but I believe we're still far away from, let's say, the good security within automotive sector. I'm not able to see the company's name or this is, I guess, because this will be problematic. But as I said, I mean, especially I have a lot of thing. I look at some German automotive cybersecurity company. They are doing great, I believe.
Okay, good. And so, according to you again, are there enough people working on vehicle security?
I would say yes. I mean, whenever I guess now in academia, let's say, whenever you go to conference, you'll see a lot of people they are doing this. I guess this is gaining a lot of attention. As I said, still there's a lot of opportunity because now, for example, whenever we speak about machine learning, that it will be embedded with the vehicle, this is itself will introduce some kind of attack surface, and you will find for example, a lot of people looking at the security with machine learning, with autonomous vehicle, and so forth. I would say that there's many people they are working in the domain, but there's also a lot of opportunity. So if somebody would like also to start this as a career, I guess there's a lot of position, especially in the industry, but also in the university, there's a lot of open questions still.
Okay.
And maybe to ask in there, so as you are at the Technical University of Munich, you're doing also education. And so from the education side, do you think that the domain is enough represented regarding chairs at the university, regarding the curriculum of the students? So is there enough specific cybersecurity education regarding smart vehicles, or would you say that it's not needed because it's the same stuff like for smart buildings, only applied a little bit differently? So how is the status of the education in that direction?
I would say that in general, I guess if you have the basic for security, this will be good start, okay? But I still believe that people, they need to know something about the design of the vehicle, what kind of communication inside the vehicle, and then they will be able, for example, to look about the vulnerability and how they can solve it. Honestly, I don't know whether there's any, let's say, program where they really teach only for autonomous vehicle and security inside autonomous vehicle. But I believe we lack in this is, and I guess we discussed it one time, I guess, that having such a thing will be a really great idea. And I already spoke with at least the people that I teach here. We are teaching IoT security in general. And I always bring example from the automotive. And after each lecture, I found many students, they come to me and said, okay, can you point us one article where they are speaking about automotive security specifically? So I believe having, for example, such a course, this will be really valuable for the student. And I guess they will prepare them for their life and industry.
Good, thanks.
Okay. A few questions again about car and insurance policies. So does insurance policies takes into account car hacking as it takes car physical attacks?
Sorry?
Does insurance policies takes into account car hacking? So if your car get hacked, could you have some insurance preventing it as if your car was attacked physically by someone? So do you know if there is some different policies of insurance?
I guess from the security perspective, there's no difference whether you are attacking the car physically, for example, or remotely.
Okay.
At the end of the day, I mean, you will manipulate something, you will violate some kind of security requirement, which means if you have a security policy which able to detect this is, I believe the policy will not care whether was a physical, whether the attacker, for example, inside, or the attacker was outside. Of course, it will alarm or tell you that there's something wrong happening. The thing that, I mean, now regarding the policy, maybe this is a good question. And as I said, I can refer to the Miller article 2019. And he was saying, okay, the fun thing that while they were attacking the Jeep, the car wasn't doing anything. The car wasn't responding. He said, okay, we go to the gateway, we install our new, for example, software, and we were doing all this. There's nothing from the car. So even, I mean, the problem now, the question whether if having a policy will be able to distinguish this is, I guess at the first place, we need to think to have such a policy. So even if the policy will be discovered that there's something wrong, okay. And as I said, from my point of view, there will not be any difference.
Okay.
So if there's any violation for any security requirement, my policy should be able to know this. Later, we'll see that physically or remotely.
And maybe related to that, so you were talking about the legal framework, and is the legal framework catching up with the reality, or is it lagging behind? Do you have insights in that direction?
Honestly, I'm not a lot involved in this, but at least I can say something about recent law in Germany. I guess they already spoke about the autonomous vehicle, I guess, in general. And I believe at least in Germany, they are thinking about now the smart vehicle and all the, let's say, of course, the security inside it. But personally, I did not read this. I don't have much insight about it. But as I said, I guess we still have a lot to do there also. from the technology, from the legal perspective, from many domains, people, they need to sit together and start thinking about this. I mean, will be always the case. So there's no system will be secure. I mean, forget the cars. I mean, your smartphone will not be secure. Your smartphone will not be secure. So at the end of the day, you will not be able to say, I will not drive the car because there will be vulnerability, or I will discover vulnerability. This is with every system. I mean, if you don't want,
there is a related question.
so as I said, I mean, we always will face vulnerability. We always will face some kind of attack against our vehicle. The thing now, what I was trying to say, and then the end of my presentation about the intrusion response system, we need to live with this, but we need also to design our vehicle to be able to protect us somehow. So if there's malicious software, for example, and suddenly there was people in one country able to manipulate it, my car should be able to respond that it should stop but it will let me, for example, able to use my car. But as I said, I mean, there's nobody should dream that we will have, for example, at the end of the day, a car with null vulnerability. This will not happen.
Okay.
I mean, if you need null vulnerability, you need to disconnect from the internet, and maybe you just use the 60s or 50s cars. I guess this will be secure from the perspective.
Yeah. And so there is two related questions to this one again. So I will just change my main question. So are old cars more prone to be attacked rather than recent ones? Because new cars have maybe a better security system, but they also have a more bigger attack surface?
I will say that this is whenever, for example, saying that I have a new car now, as you said, you have now new functionality.
Yeah.
And if the people, they don't take the security from the as we say in the V model. So if this new functionality wasn't tested, wasn't designed in security, wasn't designed, of course, the new car will not be vulnerable for the last 2 years attack, but it may be vulnerable for the current attack, which will be produced by the new functionality. So again, I would say that the modern vehicle, they may start thinking about security, will have some kind of security product inside it, but doesn't mean that they are secure. Always we will face this problem. Now, the old vehicle, I mean, if your car doesn't have the tire sensor, doesn't have the GPS, doesn't have the Bluetooth, I guess you are safe. So your car is connected to the internet, no worries.
And to just to continue with that, will it be possible in the future to have security services such as air conditioning or auto radio or everything else? So you will have some small packages of security. The more you pay, the more you will be secure.
I would like to say this is very bad. I mean, people, they speak about this this is my right as driver. Now, I guess, let me ask the question differently. When you buy a new car, I guess they will not say that there's some safety thing that you need to pay for it. They said, okay, the car is safe, it tested 100 times, and if it crash, I mean, the XYZ will happen. Okay, so the safety, you will not pay for the safety because this will be included in the car. I believe this should be the case with security. So I should not pay extra money to get my system secure. This is just ridiculous. Okay, so I guess the provider for the system, they need to be providing security as a part of the product. So I should not pay to be secure. I should be secure in the first place. And let's say this is, as I say, this kind of misunderstanding, because if you provide a system which is vulnerable, this may lead to safety issues. I mean, there's no incident till today that attacker able to kill somebody inside the vehicle or to cause the car to crash. But this is possible somehow. Okay. So if you tell me that, okay, I buy a car and I need to pay extra €1,000 to get security, this will be the issue, I guess, from the provider, because the car is not safe in the first place, because now it maybe will be crashed and I will be killed. And if this is the case, I guess from the legal perspective, if the reason was from the provider of the car, I guess you can go to the court and let him, for example, pay. I guess this should be the case. So we should not pay money to get security, and the security should be the responsibility for the provider.
Okay.
Okay, related to that, the big question with cybersecurity is always it does not pay off because it only pays off when you have an incident. Okay, and so what you say would basically require a legal framework to force the manufacturers to do it, I would say. So would you agree to that? Or would you say, yeah?
I guess this should be the case. I guess they already, the UN, I guess, the regulation, this is, I guess, just also, I guess, announced, or they are working, this is for the certification of all the vehicle. I guess this is good step, but still, as I said, I mean, the law should protect the user of the vehicle. And if the law protects the user of the vehicle from, let's say, safety issues, it will be also same for the security. Now, I guess this will be a big issue because the provider will say, okay, I did not wrote the software. The software was written by some other company, so who should I blame? I guess this should not be the problem of the user. I mean, at the end of the day, you will get a car. This car need to be secure, okay? If there's an incident, I don't care who should I blame, but somebody should pay for it. And I guess the law need also to enforce this somehow.
The incidents with the or self-driving cars pushing the need for security?
The autonomous
As
driving?
autonomous cars, are they, or autonomous driving, is it pushing the need for security from your point of view? Or would you say, well, it's another mode of driving, but in the end, you have the same needs?
I guess I would not distinguish between, I will take the connected vehicle and the autonomous vehicle the same, for example, from the perspective of security. And both of them need to be secure. And as I said, I believe now if we imagine now after 10 years, for example, we don't have drivers, all this vehicle, for example, is running autonomously, and there's a security vulnerability, I guess this will be really big issue. I mean, denial of service for all the vehicle in one city, I guess this will be a really big attack. Which means now with autonomous vehicle, I guess even government need to think about this. So autonomous vehicle absolutely is pushing towards cybersecurity, but I would say it's the same like whenever you have connected vehicle.
Okay, get it.
But I guess with autonomous, as I said, now the problem, there will not be driver. So the vehicle will be alone by its alone. I mean, whenever we speak about the level 4 and 5, and security there, it will be problematic in somehow. And as I said, unfortunately, till today, the example that I was providing with over the air update, having the idea that I have a car with malicious software and I need to wait 1 week, for example, to get this update, this is just ridiculous. I mean, I guess nobody will accept, for example, that you have a phone where this phone, you know that there's a vulnerability inside this phone and you still use it. Okay, so this will be a problem. You need to just do the update directly for this. Now with a vehicle, it will be the same. Now with autonomous vehicle, the problem will be even bigger. So there's a lot of work for security there. And not only, I mean, from the researcher, from the provider, and from the government, and from everyone. They need to sit together, they need to speak, and they need to find a solution which make, again, we still say the safety of the passenger. We need to protect the safety of the passenger. And again, I would repeat it, I guess I repeat it many times. Security accident, they may violate the safety. It's not about, for example, while you are driving your car, that the air condition was running or that the air condition was stopping. At some time, if I'm able to stop the air condition, I will be able to stop the engine. And by stopping the engine in the highway, I guess this will be, you are killing the people inside this car somehow.
Okay, that's a very good answer. Thanks a lot. So to be a little bit to deepen or to be a little bit more concrete in that direction, when you have self-driving cars, you collect data about the environment and send them typically back to a manufacturer that is having a big data lake for learning. So this might affect your privacy. You have driving decisions, the well-known example of the crosswalk where there's an elderly, a younger, and a child, and the car has to decide what to do. when we think about connected cars, there are new attack vectors, like if my car is malicious, someone infected it, or the manufacturer misprogrammed it, it sends out updates or infos to other cars that might irritate them. Will cybersecurity incidents are they likely to increase because of this increase of complexity, or would you say so the people working on it like you have it under control?
I would say it will increase because, as I say, the problem, as much we have, for example, interact with the outside world, we have bigger attack surface, and we have bigger opportunity for the, let's say, the attacker to interact with my car maliciously. And yeah, the nice example that you said, even if you car malicious now, it will not be alone malicious, but it may affect the other vehicle in the road. Okay, it will affect, for example, other security or other safety issues for the other people. So I would say yes. I mean, having more connectivity, it will mean that we have more security vulnerability. In principle, let's say.
Well, I don't know, Alex, you have something in that direction. Otherwise, I would have also another question, but I leave it up to you to decide who asks.
No, there were questions a bit related. For instance, that does car hacking happens more while the car is running or when it is parked or when it is stopped?
Both cases. I mean, you can look at famous YouTube video where the people, they were able to steal the car while it was stopping by doing the relay attack. Okay, you can also see Miller and his friend attacking car while it was running in the highway. And as I say, this is 2015, so you can imagine now in
Yeah.
2021, maybe we have, as I said, till today there's no, for example, actual attack saying okay, I was able to control the car, stop it. But the person who was asking, I just recommend to look at these two examples to see that even if the car is driving, you are able to compromise it. Even the car stopping, people, they were able to hack it, or they will be able to steal it. So it doesn't mean that it needs to be stopped or it needs running. The vulnerability is there, so you are able to use it and to control the car.
Okay, so just another question with this topic. So how are over-the-air updates secured today?
I would say that there's still a lot of work need to be done. Personally, I guess I have an experience in 2017 when we were in one conference and there was one, let's say, car manufacturer, and they were speaking about over there update like in a dream. They say this will not be running in, let's say, 10 years next, and they are famous, let's say, car provider. I would say that it's not already there, but I guess now after looking at the ISO 21434, they are pushing toward having this, because now it's, you need, whenever you have a vulnerability, you need to provide a patch, you need to provide an update. And I guess, let's say the optimal way to do this is not to back to the factory or to the provider. You need to have this is over there. Still, from the research point of view, let's say about this example, there's a lot of research about this is because most of the people, whenever they do over the update, for example, they update the whole, for example, ECU. So you have one software inside your ECU and you need to provide a new update. You just recompile everything and send it. I believe this should not be the case. I mean, we are not doing, I mean, this is from research point of view. We are not doing this with our mobile phone. So with our mobile phone, whenever we have, for example, a software and we need to update it, we just update this certain software. Now, the people in the industry, I guess, at least based on the last thing I was reading about this domain, they just, for example, take everything, compile it together, send it to you, you install it, now you have, let's say, fresh things. I don't believe this also will be the optimal things, because we need to think about a way that even at some time, as I say, this is research, not from the industry. Within each this ECU, you need to be able to move one software component from one ECU to other ECU. So you need to be able to do the migration somehow. And by doing the migration, which means that you don't need to migrate the whole ECU, you may be able to migrate one of this component to another component. And I guess this was a topic for one of the projects that I was working with. And it turned to be it's not very easy things to do. So you need to do a lot of you need to consider a lot of things,
Okay.
starting from the safety to the real-time constraint to the policy itself, and again about the security. So, but still, I guess if we are able to get, let's say, the dummy over the update, it's fine. It's still better than nothing.
Okay.
But I would say
Right,
that there's some companies they already have this functionality already there.
maybe related to that to prevent Alex from asking the next question. So the what was Tesla a game changer? So now to be more explicit, so Tesla is a software company that put wheels on the smartphone or on the software, and so they have a quite different work mode, to my understanding. So did they change the cybersecurity landscape for connected vehicles?
I would like to say that they were one of the major player in this, and I guess what they were doing, it was really, let's say, pushing the other people to do the same. And I guess back to the story 2017, people, they just say, okay, look, Tesla doing this. I mean, if you speak about over-the-air update, I mean, Tesla can able to provide some kind of over-the-air update. Okay, so why you are not able to do it? So I would like to say, yes, I guess Tesla is doing great in that perspective. And I guess now not only Tesla, there's other manufacturers they are able to provide this. But still, I guess, back, I'm not in the industry, so I can again speak about the research. As I said, there's a lot of things to be done regarding the over-the-air update. There's multiple, let's say, research questions that need to be solved and still open.
And related to that, do we have software-driven cars today? Would you say the cars are driven by software today? Yeah, not in the literal sense that the car software is driving autonomously, but is software the key component of a car today? Or would you say, even if you would have a total system shutdown of the software components, the car would still be able to operate?
I would say yes, I guess. I mean, again, looking at Tesla, they claim that, I mean, the software is leading their vehicle somehow. So I would like to say yes, at least based on the knowledge that everybody is able to read, for example. I don't have insight on it. I would say yes.
Okay, and that leads me back to Alex.
Okay, thank you, Mark Oliver. A few questions again. So two of them are kind of linked. What is the most important threat vector of a modern car? And what is the biggest security problem with today's cars?
As I said, I would like to say that the biggest security problem, it's that the people, they don't think about security. So as I said, I mean, we don't need a revolutionary solution here. Okay, you have a communication, you need to ensure that there's integrity for this. Okay, so you need to be sure that nobody was able to manipulate this. You have, let's say, privacy-related information. You need to be sure that this was encrypted with the right keys and nobody's able to store it, or even if it's stored in the cloud and somehow, okay, only authorized people are able to reach it. So I would like to say that the most problem with the security in the automotive domain, it's some people, they don't think about security, or some people, they don't take security serious.
Okay.
And this is the big problem, I would say. If some person would like to ask about, for example, certain component inside the vehicle, I guess there was a lot of vulnerability there. I mean, if you look at the Bluetooth, for example, there was many. If you look at the GPS, there was many. If you look at the tire sensor, for example, there was many. So looking at the literature, you will find always some attacks. So I will not say that there's one of them will be the most famous one or the easy one to target, but I would like to say usually all of them, if they're not protected, they are a good attack vector or attack surface that the attacker will be able to use.
Okay.
Related to that. So what if you know it, I don't know if you know it, but what would you say were the most relevant cyber attacks of the past 2 to 3 years, if this is a good time span? So is there like a top list, like, okay, wow, this was really a new quality of cyber attack? Or is there something like, okay, there's lots of attacks that are going in this and that direction? Do you have experience in that?
I guess the slide that I was showed in the start, the Miller and Charlie, I guess this is the most, let's say, serious one, because they show it, they demonstrated, and I guess they opened the eyes about this. I believe they are the father of, let's say, the debate of cybersecurity. And also later there was
Could you briefly recap what the attack was?
The attack. They were able to control the chip remotely, and before that, most people, they said it's not possible, for example, to do this. And what they were doing, they say, okay, no, because all this connectivity, for example, if I am able to look at the gateway and just update this gateway, because this gateway wasn't checking the integrity of the code that it's running, they will be able to control the vehicle. And after that, I guess many people, many manufacturers, they start to look at, okay, I need to ensure what kind of code that I'm running in my hardware. I need to be sure that this code is the code that I was putting there. Again, in 2016 or 17, I guess if I'm not wrong, it's called the Keen Research Group, which was Chinese research group. They were able to hack Tesla twice. I guess this was also very good example. But again, if you also read the paper of Miller in 2019, he said he a little bit disappointed because there's not much fancy attack against the vehicle today. And I would say yes. I mean, we still, in the last 3 years, for example, if you ask about the last 3 years, if there's, let's say, fancy or 60 attack against vehicle, there's not much. But all this, the keyless attack and etc., it's nice, but I guess it's not really as fancy as the one in 2015.
Okay, cool. And when from the other side, what are the big topics the security of the connected cars is working on? So is it securing the over-the-air update? Is it securing the communication? Is there a trend even to be seen, or is it like different groups working on different things? Because everything is important.
As I said, different group is working different things. So I can speak a little bit about what we are doing, for example, recently. So what we are doing now, we are looking at the vehicle to cloud communication. So we say that not only V2V, but also sometimes your vehicle need to communicate with certain service in the cloud. And we say that this is the information that you share with the cloud. It's kind of privacy related information. And you need to be sure that this will not be read by the people who control the cloud, okay, or any other one in the way. And our group was able to present a paper in this year in date conference where we said, okay, we are able to provide a mechanism to secure this is using MQTT communication. We also recently got another paper which is about the data itself. So if you remember, I was telling that getting the data, it's really critical. So if you go to a manufacturer and say, can you give me a data to test my intrusion detection system? And he would just say no. Or they will give you just a data which is not raw data, but data which is already handled. And this will not be useful for you. So what we are also doing in our group, that we create, let's say, a framework which is able to generate such a data. And by looking at the simulator that it's used for the autonomous driving, like a Kala, we said, okay, we run our simulator, and from this sensor inside the simulator, we try to create some kind of data. And not only data, we try to create attacks for this data. And by generating this data set, we said, okay, this could be used now by the people who are working in the intrusion detection system to see whether their mechanism is efficient or not. Of course, it's not the optimal, but at least we believe this is something that's still missing. Okay? We don't have a lot of data set that we can use. As I said, you can find other people, they are working with now heavily with the AI and security with an autonomous vehicle. Some people, they're still doing the over-the-air update because, as I say, there's a lot of things to do there. People, they are doing about also V2X communication and how to secure it. Some other people, they are looking about the identity management and how we can build the trust between all these vehicles. So as I say, there's a lot of topic. There's a lot of group working about different questions there.
Good.
So a few more questions again. So some very precise ones. There was an issue with insecure car keys some years ago. However, not much seems to have been done. Why?
I would say yes. So not much from the perspective of protecting the car, or not much from the attacks. Let's say, if we say it from the attacks, I believe that the
I
the
th- yeah,
problem, the
I think
problem
the person writing the question just asking that he or she have heard about some attacks with insecure car keys, but he or she doesn't have seen anything yet in newspapers or in technical reports. I think this was the point of the question.
I guess she or he referring to the, let's say, the attack against Volkswagen, I guess, the keyless attack. Let me say something now. I guess in the both direction, I believe that now the Huawei, they already solved the problem.
Okay.
So I guess the thing now, whenever we have an attack, I guess the industry, they are forced to do something. Of course, this costs them money and costs them everything, but I guess they would like to have their secure system somehow. I would say that they're not much from the security researcher or the people who will be able to do some kind of fancy thing like what Miller and Charlie they were doing. I guess the problem because there's not collaborative between the industry and the researcher. Now, if I would like to hack a car, I guess I need to buy, let's say, fancy car which costs tons of money, which it will be difficult, for example, to get it and to play with it. And because also, as I say, the big provider, they are maybe not interested, or they not would like to bring, for example, researcher to their domain and say, okay, look, can you play with this? Can you find vulnerability in my car? As I said, I guess the collaboration between the industry and the research, this is the one of the biggest problem. So I believe if at some degree that company come to one university and say, okay, we have this car that will be released, for example, next year. Can you find any vulnerability? I believe there's a lot of smart people. They will be able to find vulnerability and they will be able to create, let's say, fancy attack against this. But as I said, it's the truth that even in the academia, we don't have this a lot of money to buy a car and to destroy it. Okay, so this is kind of a problem. And because of that, as I said, I mean, personally, even if you look at my work and all other people work, always we try to use some kind of demonstrator which is not realistic. I mean, even the people in the industry, they look and, okay, you are using Raspberry Pi to evaluate your system. We are not using Raspberry Pi, we are using XYZ hardware. Yes, but because I can buy one of these ECUs, but I mean, I need more realistic system. And getting this more realistic system to cost a lot of money. And there's no way to avoid this is except if the companies themselves, they have some kind of collaboration with research in a good way. And provide the test bed that you are able to play with it and test it.
And why don't we see more attacks like that? Because especially also this keyless go and also keyless car open attack, where I just replay the signal to the bedroom of someone and I can just open the car. At least this is how it is in the videos. So is the underlying question is what is the risk there? Is the risk analysis it's happening 3 times a year, and therefore the cost of updating the mechanism is higher than the problem that it costs, or would you say, okay, it's updated in the background and therefore we don't have so many attacks in that direction, or is the attack super difficult and therefore it's not seen widely?
It could be all of them, but I guess I believe at least, for example, the JIB issue, the company was forced to return, I guess, 400 million car and update them, okay, to fix this issue. I believe this is also the same. I mean, if the company, they have over the air update, I guess they already update their system and the issue solved it. And this is could be not, I mean, all the provider, they are vulnerable for this. I mean, some company, they don't have, the problem is you design a software and with this software, there's a vulnerability. And not all the company, they are using the same software. So maybe the keyless attack can be applicable to certain vehicle, but will not be applicable to other vehicle. So the attack that you can face Tesla will not be, for example, the same that you be able to attack BMW. But as I said, I guess we are not able to see now fancy attack, not because the car now more secure, but I guess because there's difficulty for people like me to be able to access this vehicle and try to do pen testing for it.
Okay, good. Alex.
Okay, again, a few questions. So you were speaking during your presentation about risk analysis for cars. So what are typical components of a risk analysis when it comes to cars?
I would not say that I was speaking about risk analysis because I was speaking about threat modeling. So we believe that what we were doing, okay, this will be the first stage for the risk analysis. And I remember last talk it was about risk analysis, and the talk was mainly also about the automotive and the ISO, the recent ISO was released. So still, as I said, I guess there's no also a method for even risk analysis that you said, okay, you need to use this risk analysis and you will be fine. It's the same like the threat modeling. It's not defined and people, they use differently. Personally, I guess the EVETA risk analysis, which is, I guess, most of the people they are using, if the people, they use it correctly and they understand what it's going on, I guess this will end up in, let's say, a good security analysis there. But personally, I'm not the right person to be asked about, let's say, the risk analysis or risk assessment.
Okay, so a few precise questions and then some NIOV questions. What is the difference between a CAN bus or an Ethernet network in terms of security?
Good. This is very, very interesting question. So I am that big fan of the Ethernet, and I believe now we should at some time be brave and say, okay, we should not use CAN, okay? Because if you look, we are using Ethernet for ages now, and we are using this is for our computer, and we are very familiar with this. There's a lot of protocol that we are able to use it. Although we will not use the same Ethernet that we are using our computer and the vehicle, but at least will be the same idea. And I believe there's a lot of people, not only people who are interested in automotive, they are doing security with automotive with Ethernet. I mean, everybody, for example, doing network security, and they are using, for example, the Ethernet, you will find they contribute to the security there. So I guess there's a lot of solution there. So I believe at some time, the industry, in fact, the automotive industry, they need to move to the Ethernet. Although we are speaking about this now 10 years, I guess even before I start all this, there was people saying, okay, in the next few years we'll be moving to the Ethernet. But now the good news is that some companies, they already include their automotive Ethernet inside their vehicle. So if you recall the slide that I was showing about the domain, so they said within each domain we have this gateway, and this gateway will speak now Ethernet. So between the central gateway and the other gateway, we'll have Ethernet now, and we will keep the CAN. I believe if we move to fully Ethernet, after this will be standardized, and we look at it, I mean, from other aspect, but from the security perspective, I believe this will be far better than the CAN. And I guess we don't need to find a solution for something that wasn't designed for security in the first place. I mean, CAN wasn't for security. And I guess we can get the same benefit that the CAN provide if we have, for example, Ethernet, automated Ethernet. So why I not gain this is plus security.
Okay.
So hopefully at some time people will move toward the automated Ethernet, and hopefully this will make the security even better there.
Okay, great. So one or two technical questions. So this one was about your, we'll say, a normal control function that can detect if a behavior is not normal. So the question is, the red-orange zone flagging for tasks is nice. Does it work assuming a continuous value to monitor? What if attack equals discontinuity on these values?
This is very good question. Actually, we are not able to cover this.
Okay.
So if you look at the work that we were providing, we were defining this red zone area based on the, let's say, temporal behavior.
Yeah.
And in my case, I was focusing something about the real time, and we said that the time is continuous, for example. So you have your task is running, now the execution time or the response time increasing at certain bound, you enter the red zone. Okay. You can take the power measurement also somehow in the same. You can take the use of the memory the same. But if there's an attack which jump directly from the green area and to the, let's say, the black area, there's no way to discover.
Yeah.
But usually, I will not say, in most cases, this will not be the case, because maybe if this task is malicious, okay, maybe the attacker tried to do something. And by trying to do something, maybe he's not jumping this, for example, the big jump. But if this is the case, there's no way. I mean, the red zone will not be able to discover this. We will just moving from the normal to abnormal, and we kill the task.
Okay, right. So, and for the technical questions, there are only two questions about the NIOV project. So, which are the partners for the NIOV project, and what is each one's role?
I guess there's many partner. I don't remember all of them, of course. If you go to the website, but
Okay.
we have a people from Greece, we have a people from France, there's people from Israel, there's from Spain. So it's let's say Sweden, of course. Sorry if I forgot anyone, but I guess we have some kind of good combination between let's say industry and between academia.
Okay, and so the last question related to this topic: how will NIOV make future car more secure? What is the path of the research towards the market?
Good. Mainly, if you look at my presentation, I was focusing mainly about inside the vehicle. And I was lucky enough when I was joined TUM that to join this project because NIOV are now looking at the V2X communication, for example. So the main focus of NIOV now, if I have the communication between the car and the cloud, if I have, there is also part about how we can build the trust. So we are looking at something about blockchain identity management to identify each car and the communication between them to build trust. The incident response system, this is something that I guess we are willing and want to achieve. Something about the recovery for our inside vehicle, okay? So I believe all this is a good topic, and still there's not, for example, a product for it. So if the question is how this is will, let's say, provide for the industry, I guess it will provide, not because I'm working the project, but I guess there's will be a lot of benefit from this project because, as I said, it's speak about something that it's already hot topic and new in the domain of V2X communication, for example. As I said, mainly, for example, the blockchain things now, it's trendy. And you can find, for example, many publication or many work that we are trying to use, for example, blockchain and identity management to build the trust between the vehicle and the cloud and vehicle and the infrastructure.
Okay, very good. So that's all for audience questions. Back to you, Mark Oliver. And thank you again, Mohammad, for your presentation.
Yeah, thank you very much, Alex, for the great moderation as usual. So maybe as really last question. So what should be the take home for the audience of your talk?
I would say that they need to understand that security is really important, and not only in the automotive, for example, domain, everything. I mean, we should start really thinking about that security should be something important in our life. And now, if you look at the automotive, this should be critical because you are driving a car which may, if there's a vulnerability, if there's a security incident, it may kill you. Okay. Other takeaway, for example, people they need to take also from industry part. They need to take security and much serious, and this is need to be involved and consider as equivalent to the safety. Other thing, for example, takeaway for the people or the student, for example, I would say that the domain still need a lot of people, a lot of researcher. If you plan, for example, I guess to do PhD or do research, I guess this is very nice domain to start working in. And I guess you will learn a lot and you will contribute a lot because, as I say, there's a lot of things to be done. Hopefully I cover everything now for the audience, hopefully.
Very good. Yeah, but I mean, there's lots of very good take homes. So yeah, so thank you once again. A big thank you to you because it was, as always, it was the first, as I told you also before, the presentation part super interesting for the audience, and the discussion part is at least equally interesting and important because we always have great questions. So thanks a lot also to the audience for the great questions. Good. So that brings us already again to the end. We spent a good 1.5 hours together. So as you see on the left side of your screen, so on the right side of me, there's again the flyer for the PhD school. Yeah, now it's bigger. So with the PhD school. So if you have time next week and are interested, have a look at the website https://school.future-iot.org. There we have the program, and it will be as comfortable as joining this series here. All right, besides that, let me just switch back to us three. Besides that, the series, of course, also has a December edition. As in December we have Christmas, we put it a little bit earlier, so the next edition will already be on the 15th of December. so more or less in 2 weeks or in 3 weeks. And no, in 2 weeks, in 3 weeks, okay, yep. And the speaker there will be Oliver Wohlfeld, and he's at the TU Brandenburg in Germany. And Oliver will be talking about DDoS attacks and booter services. So make sure you mark it in your calendar and join again in 2 weeks for the last edition of this year. We'll also do a quick wrap up. Thank all the speakers again. So thanks for participating, and see you in 2 weeks.
Thank you. Bye.
All.
Bye-bye. And,
Cher CyberCNI, pôle d'excellence région Bretagne. Au revoir et à la prochaine.